Hi everyone and welcome to the internet. What we're going to be doing in today's lesson is having a look at nuclear equations. So hopefully by the end of this lesson you're going to be able to write out these balanced equations for the different types of nuclear decay. To start us off though, we've got a couple of questions based around the work we did in our previous lesson. So have a go at answering those two questions in your book for me. I'm going to give you about 4 minutes to do that. Okay, let's check those answers then. So for question 1, hopefully we got alpha, beta, gamma and neutron. Give yourself a tick for each of those you got right, maximum of 4 obviously. For the second one, the experiment that we could actually do, then there's several marks available for this. So give yourself a tick if you said we're going to use a Geiger counter with the radioactive source in front of it. Your next mark comes if you said we place a few sheets of paper between the source and the Geiger counter, and you get another mark if you said that if the count decreases, then alpha particles are present. The next mark is for saying we place a few millimeters of aluminium between the source and the Geiger counter, and if the count decreases, then beta particles are present. So give yourself a second mark for the comment about beta particles. Then your final 2 marks are for talking about the gamma. So you get 1 mark if you say you place a few centimeters of lead between the source and the Geiger counter, and that second one is for saying that if the count decreases, then gamma is present. So really what we're describing there is that experiment with our Geiger counter and our radioactive source, and then placing the different materials in front to see, does the count decrease? If it does, then obviously it means it's blocking some of that radiation from reaching the Geiger counter, and we know that those different types of radiation have different penetrating powers. So add up your scores and give yourself a total out of whatever number that was. It's quite a few, I think, there. So add it up, write it in your books for me. So our first actual nuclear equation that we're going to look at is the one that we use when we're talking about alpha decay. So in alpha decay, we are going to be releasing an alpha particle. Hopefully the name kind of gives it away here. So what I've given you at the top is one of these nuclear equations. So what we've actually got on the left hand side then is our plutonium. So we've got plutonium-240, and we're then going to be making uranium-236 and an alpha particle. And hopefully we remember an alpha particle is a helium nucleus. Hence why we've got the He as the symbol there. So what I want you to do is write down the top equation for me as it is, and then have a go at answering the question underneath. What do you notice about the 2 sides of the equation? So I'm just going to give you about a minute and a half to write down the top bit and answer the question in your book. Hopefully what we've written down about what we notice about the 2 sides of the equation is that they add up to the same values for both the mass number and the atomic number. So if we look, plutonium has a mass number of 240, and then if we look at the right hand side of the equation, we've got uranium with 236 and helium with 4. So 236 plus 4 gives us 240. If we do the same with the atomic number, plutonium is 94, but uranium is 92, helium is 2, so 92 plus 2 also gives us 94. So the key thing there is that both sides of the equation, the atomic number and the mass numbers, add up to the same for each side. Okay, your turn to have a go this time. One of the types of questions they do like to use on the exam papers is they will give you part of one of these nuclear equations and you've got to fill in the missing bits. So I've given you part of a nuclear equation at the top there. I want you to fill in the missing bits. Now, you probably want to grab hold of a periodic table to have a go at this. Hopefully you've got one in your book there. So I'll leave this up give you a chance to look about a minute to do this one. Get it written in your books. So what we need to do for this one then is we've been given the left hand side, so we've got uranium-236 over here, and we've been given the fact that it is alpha decay. So over here we've got our helium. Now if we remember, we can work out what goes in these two boxes purely by subtracting from this. So if we've got 236 on the left and we've got 4 there, then we know that our top number is going to actually be 236 minus 4, which is 232. We do the same for our atomic number, so we've got 92 on the left, and our helium actually has 2, so 92 minus 2 gives us 90. So we've got our two numbers there. All we then need to know is what element is it. So if you look up on the periodic table, you look for your atomic number of 90, and what you'll find is it's thorium, so it's TH. So give yourself a mark for each of those. If you got the 232, 1 mark, 90, 1 mark, and the element symbol is your third and final mark. Add it up and give yourself a score out of 3 for that one. So the second type of decay we're going to be looking at is beta decay. Now in beta decay, what we're going to see is a neutron is going to decay to form a proton and an electron. Now what we're going to find, that electron that we're forming is going to be emitted as our beta particle, that fast moving electron. So that's the bit that's been given off, if you like. But within our nucleus we have seen a neutron decaying into a proton and that electron that we've lost. So don't forget the proton is also formed here. So write down the top sentence for me in your book and then see if you can answer the question underneath. Again, write that in your books. I'm going to give you about a minute to do this one. Okay, let's check those answers then. Hopefully we managed to point out that in our beta decay the number of neutrons decreases by 1 and the number of protons increases by 1. So even though we're losing a neutron, we are gaining a proton. So make sure you've got those points written down if you don't already. I'll leave those up for about 30 more seconds. Let's have a look to see what that means in terms of our nuclear equation then. So again, the equation at the top, you need to write that into your books for me. So what we've got there then is we're going to start off with carbon 14 on the left. So carbon is going to have a mass number of 14 and the atomic number is 6. What we find in beta decay then is that we're going to end up forming nitrogen and our electron, the fast moving electron, the beta particle. So what we've already said is that our mass number is 14 there, okay? So we're not going to see that change. And then we're going to see our atomic number go from 6 to 7. Do remember, obviously, the different numbers we've got to associate with our electron: 0 for its mass, -1 for its atomic number. So write down the top equation and then have a go answering the 2 questions underneath in your books for me. So I'm just going to give you another couple of minutes to get that done. So when it comes to talking about the mass number in beta decay, then it's not going to change. If you look at the equation at the top, we can see carbon has a mass of 14 and nitrogen the mass number of 14. Now, the reason that the mass number is not going to change is because the total number of protons and neutrons is the same. We may be losing one neutron, but we are forming one proton. So the mass number, remember, is the number of protons plus the number of neutrons. So if you lose one neutron but gain one proton, it just doesn't change. It stays the same. So still 14. If we think about the atomic number in this case, remember your atomic number is the number of protons there, then we are forming a proton by that breakdown of our neutron to form the proton and the electron. So that means that our atomic number will go up by 1 because we're going to be producing one more proton. So we go from 6 to 7 in the example I've given you there. So make sure you've got those 3 points written down in your books. I'll leave this up for another minute in case you haven't already got those. Okay, your turn again. Have a go at answering this question for me. Write down the nuclear equation for the beta decay of cesium-137. So again, you want to get your periodic table out to help you with this. So I'm just going to give you a couple of minutes to have a go at writing that nuclear equation in your books. Let's have a little look to see how we answer this question then. Write down the nuclear equation for the beta decay of cesium-137. So first thing we pull out is its beta decay in our question. Now hopefully that does tell us that during beta decay a neutron is going to decay into a proton and an electron, and that's going to then be emitted. So what we're going to find is the neutron number is going to go down by 1, but the number of protons goes up by 1. So to start this off, we're told it's cesium-137. So the first thing we need to do is get a periodic table and have a little look to see what is the atomic number of cesium. And the answer to that is 55. So cesium has an atomic number of 55. Now in beta decay, remember what we just said, a neutron decays to a proton and an electron. So that 55, the atomic number, tells us there are 55 protons, but if we're forming another proton during this process, then we need to know what element has the atomic number of 56, because we need to add 1 onto the existing atomic number to make that extra proton be counted. So when we look at our periodic table, we'll find that that is barium. Now the next thing we need to do then is actually write out our equation. So we're going to start off with our cesium. So we put cesium first of all, and we can see the mass number is 137. So 137. And its atomic number is 55. So 55 goes to the bottom. Now that is going to undergo this process of decay to form our barium, as we've just said, and an electron. Now hopefully you remember that the electron is 0 in terms of its mass and -1 for its atomic number. Now that's our electron done. Then we need to fill out our barium. So we've said that the atomic number is 56, so 56 goes at the bottom. And the mass number, remember, we may be losing 1 neutron, but we're gaining a proton. So that just stays the same. So it's just 137. And that is all we need to do to get the answer. Okay, our third type of decay then is gamma. Now, hopefully we remember from some of our earlier work that gamma is actually an electromagnetic wave. So because it's an electromagnetic wave, it has no mass and no charge. So what I want you to do is write down the top sentence and then have a go at answering the question underneath in your books. Just going to give you a little bit over a minute to get that done. Hopefully the answer we got written on our books is that there is no change to the mass number or the atomic number. And the reason for that is that because gamma is an electromagnetic wave that has no mass, no charge, it doesn't change either of those things. So if you haven't got that written down, jot it down in your books now, just another 30 seconds to get that done. The final type of decay we need to look at is neutron decay. So what we're actually seeing here is that when certain nuclei are decaying, we're going to produce large numbers of neutrons. And in order to make that stable, those neutrons need to be emitted. And a really good example of this is a substance called helium-5. So we can see we've got our equation there. So we start off with helium-5, so the mass number is 5, atomic number is 2, and it's going to form helium-4, so the mass number is 4, the atomic number is 2, and it's also going to emit a neutron, okay? So the symbol for our neutron is a lowercase n, remember, mass number 1, and its atomic number is 0. So what I want you to do is write down those points and then have a go at answering the question at the bottom on what is the impact on the charge of the nucleus. So I'm going to give you a couple of minutes to get that done. Hopefully what we said is that there is no change to the charge on the nucleus because neutrons have no charge, and the nucleus is more stable after that neutron emission. So make sure you got those 2 points written down if you didn't get it right. If you did get it right, give yourself a nice tick. Last thing to do today, as always, is our plenary questions. So if your target grade is up to a grade 5, it's the 2 columns on the left. If your target grade is over a grade 5, it's the 2 columns on the right. So I'll leave this up only for about 30 seconds today, so I'd suggest you hit pause on the video to actually have a go at answering these questions. So hit pause now so that you've got a chance to answer these in your books for me. As always, you can find the answers to the plenary over on my website, sciencewright.weebly.com. You'll also be able to find that under the Internet tab. Just select the week that we're in, and then you'll be able to find things like the lesson PowerPoints, the answers to the plenary, any additional work, and if there's any little experiments I thought you could do at home, then they're there too. So have a look and get using that.